Hey everyone, Phil here. I've got 3 minutes to try and convince you that every test stream you run should have captions. Let's get started. First of all, sorry I'm not in San Francisco. I'd love to be there. My dad's in the hospital, unfortunately, and I decided to stay here and spend time with him and my family rather than travelling right now. Hopefully I'll see you all at Demuxed 2023 in Europe, right? Demuxed Europe's going to be a thing. Matt said so. One of my passions in the video streaming space is accessible streaming video content, whether that's captions or subtitles or audio description. And this is actually so true it even appears in my Hinge profile. True story. If you don't believe me, ask Matt. It's absolutely true. I've been called the captions guy or the subtitles guy at a few jobs, and I blog about this sometimes, including this frustratingly popular blog post, which probably says more about the state of some of the captions flags in the HLS specification than my ability to talk about it. Let's start with a question. How many times did we see Big Book Bunny yesterday? It was quite a lot. And how many times did that Big Book Bunny have a captions track on it? Well, none, because there isn't a captions track for Big Book Bunny, right? And this isn't me calling out anyone who uses Big Book Bunny as test content or anyone who talked yesterday. This is just a fact of how we generally tend to test. But it's 2022. Accessibility cannot be an afterthought, especially after what Dan talked about yesterday. Every time we test playback, we really need to start testing captions as well. But like I said, this is a problem. Here's a problem statement, right? This is a problem because Big Book Bunny doesn't have a captions track. So what do? Well, we could use a captions test sequence from, I don't know, the WebVTT spec, for example. Never drink liquid nitrogen. First example in the WebVTT spec. Or we could rip some captions off another piece of content, like Tears of Steel, and put it on Big Book Bunny. But then we don't have any synchronization, and where's the fun in that, right? So I sat down on Sunday night, I think it was, with Premiere Pro and a couple of cans of beer, and I authored a captions track for Big Book Bunny. And here's some huge disclaimer. I am not a professional captioner. I'm just not. But I did pick some of the best moments. I've captioned the whole thing, but here's some of the best moments that you'll see. First of all, the bunny sniffing, ears popping, and of course he gives a big yawn, right? Okay, there's the first one. There's some caption content. Some jovial music, obviously, as a bunny skipping. Just some highlights that you are going to enjoy at some point, I'm sure, of the bowstring pinging, the vine snapping, and the poor squirrels eventually getting squashed, obviously. And of course, the biggest highlight of the whole thing is, how do you describe a bird pooping on a flying squirrel? Yeah. Poop splats, apparently. I'm going to preempt all the Q&A, given we don't do Q&A inside the context of a lightning talk. So is it perfect? God, no. Does it conform to any form of accessibility standard? God, no. Do I know the proper names of all the characters? Look, nobody knows they're called Frank, Rinky, and Gimera anyway. Nobody needs to know that. Is it better than nothing? Yes, it's much better than nothing. Every Big Book Bunny stream can now have captions. There's no excuses for not doing this anymore. What's the license? CC by attribution 3.0, exact same as Big Book Bunny. How many times do I use the word FUD? 17. Which version did I caption? The original, obviously, the best, the OG. There's a 4K version coming soon. And what is my favourite caption? Poop splats, clearly. If you want to help out and improve this, because I assure you it is not perfect, github.com/demuxed/big book captions, big-book-captions. That's it. If you want to use them, if you want to share them, if you want to contribute to them, go there, fork them, help out. I have one more slide, which is a huge thank you to my wonderful mother who let me turn her lounge into a very ghetto studio for the keynote yesterday. Here's a fun fact for you. Thank you, Mum. Love you. £50 of lighting here and a £15 green screen and shot on an iPhone 11 Pro. Don't let anyone ever tell you need to buy an Arri Alexa and thousands of dollars worth of lighting. It's not true. You can do it on a budget. Here you go. Proved it. I'm probably over time. See you all at Demuxed Europe 2023. Bye-bye. See you all. Bye.
Good, it's Kev here in Sydney. I'm going to talk about encoding LCEVC using Raspberry Pi into MetaQuest devices and web browsers. So to start with, what's a Raspberry Pi? Most of you already know this, I'm sure, but it's extremely cheap, easy to obtain. Typically it's $35 in most places. It's got an H.264 hardware encoder, it's ARM64 compute, it's got a really good supply chain. It's largely open source, and CSI cameras can be plugged into it, and that gives you a raw Bayer input into FFmpeg. Okay, what's LCEVC? It's low complexity enhancement video coding. It's actually an MPEG standard. VNova has got the commercially available codec implementation right now. What does it do? It splits encodings into baseline with an enhancement. And by enhancement, what this is a delta between the intended resolution that you want and the baseline encoding that you have. So rather than sending multiple full frame encodings, you just send the differences. So why would you want to do that? Well, if you compare multiple encodings, you end up with a lower bit rate. Savings can be around about 40%, and that's a saving to network operators and also CDN providers. Multiple baselines can also be used, so you get H.264, HEVC, and AV1, which you may already have hardware encoders for, and lower CPU, GPU overall, which means better battery life potentially, and it's faster to encode, and you can use existing hardware you already have. Also, it's pretty easy to decode, needs a bit more compute. So how would you encode LCEVC? Well, you can do it quite easily with FFmpeg. VNova has pending PRs with Videolan. So how it works is you take your baseline encoding using your hardware encoder, and typically about a quarter resolution of your final frame. And the enhancement layer then encodes using the CPU, or if the device has a NVIDIA CUDA, can be used to accelerate this. Works on multiple platforms, on ARM and Intel, and can use the NVENC, or it can use the software encoder. There's a little FFmpeg command line example there, and also Video on Edgecaster also supports this into their Video Edge platform. And what about decoding? Well, with a browser, you can use media source extensions, there's a bit of WebAssembly, and into Canvas. You can find some working examples. Shaka Player Mainline now actually has this, which you can get from GitHub today. Kudos to Joey and Vino and the team. And also, it's easy to integrate on other browser players. So Dash.js has this, and also Theo Player has this too. And what's super exciting also is that it's also available on the MetaQuest. Exoplayer edits will be available shortly on open source. Vinova is going to do that. And the other things that we've got coming is volumetric cloud point data, which is in demo and development. What's coming next? Well, the Raspberry Pi needs a bit more love because the GPU is not being utilized quite in the way it could be. Hardware DRM has got quite a lot of challenges ahead because of the decoder due to protected pipelines and trusted execution, and watermarks can get whacked when the video is being reconstituted. And I'm also looking to saving off sideband and nuclear enhancement files for supporting things like 8K. That's it for me. See ya.
Video streaming emits a lot of CO2 in the world. It is our duty to be as lean as possible. At Lumen, like other structures like breeding or streaming do, we want to determine as accurately as possible the impact of our activities. We have identified three main contributors: CDN, network, and end-user devices, and we study how peer-to-peer delivery can affect them.
On one hand, P2P reduces the number of CDN nodes required, which is a gain. But on the other hand, P2P also increases the strain on the many end-user devices, which is a loss. Regarding network, we see through some trace routes that the number of hops is equal for both CDN as well as P2P. So we are left with a simpler question. Do we gain more by reducing the number of CDN nodes than what we lose in the many end-user devices by activating P2P messages?
About CDN, it's on and always on for a long time, like multiple years. So its impact seems to be dominated by the electricity cost of keeping it on, whatever the traffic itself. So we consider the available throughput with a safety margin, take into account the power usage effectiveness, and find, for example, that a CDN consumes about a quarter of a watt per viewer for a 4 megabit stream.
About end-user devices, we cannot get power consumption measurements from production deployment. Instead, we have set up a QA test bench with some devices and a watt meter. We have then analyzed CDN-only streaming and streaming with P2P on. For example, a laptop consumption may increase from 9 watts to 9.5 watts, and this delta of 0.5 watts is the power consumption of P2P. The results are a bit surprising. For example, we see that the increase in power consumption does not scale linearly with bitrate. This can be explained with the thresholds in CPU frequency scaling.
At some bit rates, peer-to-peer is linear than CDN, but more often it consumes more than a CDN at full load, up to 3 times as much. But CDN traffic is usually peaked, meaning it consumes energy for little use at off-peak hours. Using production traffic shapes over weeks, we have found that we could enable peer-to-peer only during peaks and make better usage of a smaller CDN with energy savings of about 25%. Exciting results, yeah?
Still a lot to do though. We need to have a deeper understanding of the problem. We need to have more accurate figures, including for native deployments. In the future, we'll be automating the measurements and tracking the results across releases. Follow our technical blog to stay updated on this topic. Reach out to us. All feedback is welcome, and thank you for your attention.
Hello and welcome to Demuxed 2022. I hope you enjoyed the event. I'm Victoria Tuzova, Business Development Manager at Alexandre. Today I'm going to share our personal experience connect with quick search and analysis of media database. So let's go ahead with massive file storage that restore one checker. Just imagine how much content we received from our clients for more than 30 years. This is a huge database with all kinds of video, audio, and media container formats. Our engineers usually test samples during development or testing processes. It would be much easier to find necessary samples in the database on the fly. So recently, our storage was a real mess. TS, MP4, not valid files, video and audio formats. So finally, Alexandre engineers wrote their own script to search for particular files. Of course, there was some existing tools, but they followed an unbeaten track. Engineers identified common architecture. They deployed checker prop in the network so anyone could manage it. First, our engineers created an app, Checker. They sorted out the files by containers and video and audio codecs that help us clear out the entire database. Then we added additional functionality based on internal QA requirements. The new task came out quickly. Engineers selected 4K HEVC files for live HEVC decoder test performance. With the next iteration, we added a feature to check resolution. As a result, we got a list of 4K HEVC files in the TS container. But then we faced two challenges. Decoder performance depended on the video bitrate. Live HEVC decoder consumed more resources, so we added a bitrate checker feature. So only files with CBR rate control went under test for live decoder performance because VBR files could not be broadcast accurately. As an app turned out so much useful for us, we decided to use it not only for task sample searching and clearing out the media database, but also for debugging. It helped us when the packetizer wrote incomplete HLS chunks after the transcoder. So engineers ran a task for searching all chunks with no audio. The pattern allowed engineers to find out the root of the problem quickly. The tool is now our internal lifesaver, and our idea is to develop it in fully fledged solution for quick search and analysis of media database. What we need is your feedback to improve our software and to better understand the market. Thank you for your time today. Please feel free to reach us out. We would be glad to share more insights, milestones, and features. Thank you.
So today I'm going to talk about how to build a CDN, a robust CDN, and some of the insight of the industry. This is just a peek of the full talk, so I'm going just to share some insights. You all know me, I've been here for a while. This is for the remote people. So one of the first insights, and this is something a lot of companies find, when there's an hourly or daytime pattern issue, that the same error is happening at the same time, or even the same day of the week, so easy. The problem is on you, fool. You are not scaling correctly. Don't waste more time searching for other reasons. The 4 a.m., the darkest hour, what happens at that time? Well, it's a classical maintenance window in all data centers, knock pops, like wherever there's a physical server. So when you are monitoring your CDN, it's normal that near that time you are starting to have a growing your 400 errors. Another one. ISPs, they always lie. Don't trust them, never. If you suspect they have something in their firewall or something that it's blocking you, just mail them and shit on them directly. Don't waste more time. This is a really interesting insight. So, and yesterday Willow mentioned that. Normally, when you are delivering video, even you have your bitrate ladder, the reality is that you, most of the times, are only serving the worst or the best. So what happens with the middle bit rates? When you are monitoring, as they are not cached as the best or the worst, it's an early detector system of problems between your mid-tier and and your origin. So when you first find errors only on this is an early detector that something is going to be worse later. So, and I don't have time, but I also built the 10 CDN commandments. Homage to Biggie Smalls, rest in peace. Yeah, I will share later in the Slack. If you can just read it fast. Another one. The conclusion is, in this industry, everybody lies. Trust nobody. Thank you.
Okay, so today I'm JP. I'm gonna try to make these fast. So how this all started, it all started with this guy here. Do you know Rod? Please stand up, Rod. It's all about you, this story. So last December, Rod, whom I met in Videotapes, texted me. We had only had one coffee in life. He said, hey, I'm in Amsterdam. There's lockdown, and I'm working alone trying to found Infuse Video. It's kind of depressing. Do you mind if I travel to Uruguay and work from Qualab's offices and stay there in the summer? Yeah, why not? Why not accepting a guy we'd never met before in our offices? So we did. And so he came. He was supposed to be there for a couple of weeks. He stayed like a month. And it was great because we shared barbecues, events, lunch, the beach, and even visited some wineries and more. But during all those sessions, all our team, we have currently like 90 engineers, video engineers in our team, shared with him. So they learned a lot from him, from his past experience, his failures, his wins. It was all about collaborating and learning. So inspired him, he said, why don't we try to replicate this idea? And that's why we created these. Why don't we invite people like Rod to come to Montevideo and do a summer camp? Just in case summer in the south is in January and February. So why that? And what do we propose? So the first is that we can share with our more than 90 collaborators, so more video engineers. You can work from our offices. If you want, then you can go to the beach. You can participate in our video events. You can be part of our internal events. We can go to incredible places in Uruguay, which we shared a few. And an extra one, you're going to have 2 summers in a year. Or if you live in San Francisco, at least 1 hot summer. So there's Uruguay, in case you don't know, next to Brazil and Argentina. And some interesting facts about Uruguay. So we have great internet access. We were pioneers in the 1 laptop per child. So we've been more than 15 years having every kid and student having a laptop. All students, public and private schools. We're the only full democracy in South America. We have low corruption compared to our neighbors, and it's cheap to be there compared to being in San Francisco. But wait, because you're going to say, but I have to pay the ticket, I'm going to be there. So what if you cannot afford it? Okay, we're offering a few grants. And the requirements is that you have to have contributed to the community. So people like JB, that you mentioned yesterday, a lot that you're contributing. So please contact us, and we're going to give a few grants so that people that are contributing all the time, we can give back and invite them to Uruguay at our expense. So if you want to know more, contact me. I'm going to be around. Thank you very much.
Hi, I'm Derek. So at some point in my career, I had to write a video trimmer. You have a live archive. You might have 15 minutes of a placard in front, some crap at the end you don't want. You want to trim it off. There's a couple of possible approaches to that. You can re-encode the whole thing. You can store some metadata, fake it on the front end, JIT it, relegate yourself to copying between keyframes, or you can re-encode the start and end bits and copy the middle bit. Or you can write a huge edit list that nothing will read except QuickTime. So I chose to do the re-encode the start and end. Sounded pretty easy. Wasn't very easy, especially when you work for a company that has 15 years of encoded user files that you have no idea what made them. So what you end up doing is copying or parsing the SPS and PSPS and knowing your encoder well enough that if you know the SPS and PPS, you could set the encoder up in a way as to generate that exact SPS and PPS, because you don't want multiple init segments, in your playlist. That's kind of ugly. It worked pretty well. It was pretty fast. You probably already see the issue with this. The clicker is a meme. So since it relied on reproducing the encoder settings, you have to assume the input is good. Turns out we didn't have all good input. And it also means, because it relies on good input, I became the sole bug triager for the entire company's stacks. Not a very fun thing to be. And it turns out there are users who may not want their HDR AVC files to be nuked if they trim it. And if you want to extend to HEVC or AV1, you need to, parse VPS and HEVC, modify the TU if it's AV1. And but the main thing I want you to take away from this is scope only expands. Let's call it the second law of scope dynamics. Yeah, so if you show you can do a thing that people said you couldn't do, and then you do it, people want you to do more things you shouldn't do. Oh, you've built a trimmer. We can apply EDLs to this, right? No problem. You want stuff rendered on top? Oh yeah, that should be doable. You just build a whole NLE. You can make it truly instant, sure. Yeah. So moral of the story: don't be me. Don't be clever.
Hi everybody. I'm Joey, and by a show of hands, who's using Shaka Packager? Packager, show of hands. Who's using it in production? Keep them up. All right. I want you to advance my slide. To maintain Shaka Packager. So, I know what you're saying. How can I maintain it if I can't even build it? So maybe you've had this issue, or maybe you've had this issue, or maybe any of the other build issues that I accidentally advanced through in clicking on this slide. So I know we're working on it, and you can be part of that solution. Right now, we are ripping out G-Client, Chromium dependencies, and JIP. We are getting Git submodules, we're using Absile, and we're using CMake. We will have a modern, reliable build system that you can recognize that will work everywhere on every platform. Please come help with that, and then please come help maintain Shaka Packager. If you are willing to take on the responsibility of reviewing changes and making releases, in exchange, you get the power to review changes and make releases. With great responsibility comes great power. So, help with the CMake port, volunteer as a maintainer, take some ownership over the direction of Shaka Packager. We would love to have more involvement from the community, and anybody at home, anybody in this room can do that. Thank you.
Okay, my name is Steve Heffernan. I work at Mux. I've been selling you all on web components for a number of years now and building Metachrome. And I was talking with Joey yesterday about how easy it would be to wrap Shaka Player and make a web component that's compatible with the video API. And so I decided to put my money where my mouth is, and yesterday, while simultaneously paying close attention to all the talks, I wrote this quick wrapper around Shaka so that you can use it along with Metachrome, or just use it as an element, and that's what this is. Don't look too closely at the internal code; it's not pretty yet. This is a POC, but it gets the job done, and it results in this an HTML element that. Looks as simple as the video tag, but now it's powered by Shaka, Shaka Player, and include it with a simple JavaScript include or npm import, any of those things that you would expect. And you end up with, if I can click on the tab here, so then you end up with the simple player. This is just the default browser controls at this point, and an element that works like the video tag. So then, I'm going to use quick keys here. Can I do this? Yeah, okay. So then compare that to, the basic usage tutorial on Shaka Player, which is, a couple pages long, which no offense to Joey, like this is normal for players and everything, but just kind of shows off the power of web components to like simplify all of this in just like a single line of code that is an encapsulated web component in HTML. So I think that's pretty cool. How am I doing on time here? Oh, I'm halfway, sweet. So then, of course, you wrap that in Metachrome, and you get a player that you can then customize the controls however you want and make it, interesting with preview thumbnails and stuff. Ignore the fact that the preview thumbnails are Mad Max, not the actual video. So yeah, that's great. The Shaka video element is built on top of this custom video element, which is really just a way to kind of subclass or extend the video element and make that really easy to then build, your own player in the same way. My coworker Wesley has a similar project called Super Media Element, which basically achieves the same thing. And then of course we saw Matthias's baby video yesterday, which I thought was super awesome. Just building everything from the ground up. More likely, if you have a player, you're looking towards the previous solutions where you're just trying to use the video element. But if you really have something custom, like I thought that was a really cool example of building really to the same goal. Here's another example of JW Player 1. We have Vimeo and YouTube and a bunch of other examples at this point. Would love to see more of the other players. And next on our list is themes. So if you're interested in building themes, kind of like WordPress themes, but for players, let us know. That's the next thing. And if you're using Metachrome at all, please let me know. It has been awesome to see all the mentions of Metachrome in the last few days. And I had no idea any of that was happening. So that's the problem with open source, is you don't get to know what people are doing. So yeah, let me know if you're actually playing with it or using it in any way. Thank you.
So I'm going to talk about scaling over multicast. So you have some live video, you put it in HTTP origin, you want to scale it. How would you do it? Everyone who doesn't know should have paid attention to the presentations yesterday. You put it through a CDN. Downside is the more users you have, the bigger qualities, the more ABR you have, the bigger costs you'll have. There is a different solution, or sometimes, and that is if instead of putting it through an HTTP origin, you put your video through a multicast sender and you broadcast, you multicast it to the viewers, and the viewers subscribe to a multicast address, receive all the video, and they start playing. Well, as they say, the truth is in the pudding, so I tried to build this myself, obviously. And I started on top of HESP. For those who don't know what HESP is, I'll quickly explain it. People that want to try this at home, you could as well have used Dash or HLS or whatever. I like HSP. So the idea behind HSP, if you do over HTTP, is you download a manifest. In this manifest, there's a list of tracks. Each track has an initialization and a continuation stream. When you want to start playing live video, you download one initialization packet. In this packet is a keyframe and a byte offset. Using this byte offset, you do a byte range request to the continuation stream, and you continue streaming for there. The reason for this double setup is that you can do very quick track switching with sub-second latency. Now, this is all unicast, HTTP. How do we make it multicast, or how did I make it multicast? So what I did was, when I have a device and I can see, okay, it has multicast capabilities, I still ask for this HSP manifest over HTTP, but I ask for a multicast version of the manifest. This still contains all the exact same data that the original manifest contains, but for a continuation stream, there's an optional multicast address you can join to receive the continuation stream. So what you do then is you still download that one initialization frame, in parallel join the multicast address so you can get the continuation stream, combine this data, and from there on out you have no more HTTP traffic and you can receive everything over multicast. If you want to know more about this or all the cool conclusions I was going to say in my next slide, you'll have to talk to me in person because my time is up.
So what I'm showing you today is basically VLC.js. The demo is working since a few days, so that's probably going to crash at some point, but that's okay, right? So what you're seeing here, yeah, so this is 4K web codec inside Chrome. So, well, it's H.264, so that's normal. What's new about that, right? So now we're going to play back other things like, oh, this is an MKV file, which is, of course, H.264. It plays, but it also recognizes the MKV chapters, and you have subtitles, including SSA subtitles that actually work. This is 5.1, downmixed to stereo. It's probably a horrible thing. Anime, I did not choose the samples. So then, well, you know what? Like, we can have VP9. That's also still web codec. That still works inside VLC. Okay, still nothing too big, right? I can do that with any player. So now I'm going to do more cool things like, well, this is TS, HEVC, playing back amazing TV shows in the US, horrible things, HEVC directly inside the web browser. All that is automatic, so as you can imagine, it automatically falls back from web codecs to AV codec. If you want, you could force that, because it's a normal VLC, and so I'm going to force AV codec here, because I want to show you that it also works with AV codec. And now, because I have AV codec, I'm going to do more fun things, which is H.264 interlace in TS with Dolby Digital 5.1 inside your web browser with no JavaScript. Works pretty fine. All the codecs from FFmpeg and all the codecs in VLC are there. Let's go on. Billiard is a very nice sample to test deinterlacing because the balls are running. It's very difficult. The deinterlacing is done as WebGL shaders directly inside the web browser. So that's actually OpenGL ES2 shaders. What else can I show? Oh, I got time? Okay, so this one is fun, right? This is DNxAG MXF 422 interlace directly inside the web browser, right? It does a 422 to 4.20, which means also I can do HDR tone mapping, super resolution, everything that. And it's, of course, automatically going to AV codec. And finally, and my last, and I'm almost out of time, I'm sorry about that. I also can do like 360 video, and like basically it's going to map the equirectangular to a normal projection directly inside the web browser. So it's a full VLC. Everything you can play in VLC can be decoded there. Once you have hardware decoding, web codecs, you have almost the same power consumption than a normal video player, and else you can play all the weird formats. Thank you very much.
My name's Todd Sharp. I am a developer advocate at Twitch for Amazon IVS. And part of my job is basically playing around and creating fun little demos. A lot different than what we've seen so far today. This is my first Demuxed, so I appreciate being here and learning from all you amazing, brilliant minds. So this project came about, it was something I wanted to work on for a while now. And when I was packing to come here, I live in Georgia, I was packing to come out to California, I threw a couple things in my laptop bag, and I thought if I have some time, I'll play around with this. So yesterday morning, thanks to the lovely wonders of jet lag, I was up at 4 a.m. So I got out my laptop, got out my stuff, and I said, let's play around with this, see if I can do it. So this is like literally something I just built yesterday. It's something I have a direction for, but let's take a look at it. So PTZ cameras, pan, tilt, zoom, they're not cheap, right? I mean, they're like seriously not cheap. There's some that are kind of on the lower end, but they can get really, really expensive. So I thought, why don't I just build my own, right? I decided just, my buddy Prince Michael here decided to build my own. So I went ahead and I built it. So yesterday, as you can see here, this is a kind of a little bit of an architecture drawing, but I have an Xbox controller, and in the browser, there's a gamepad API. You can actually pair your controller to your computer with Bluetooth and listen for connections to that gamepad and listen for events from that gamepad, button presses, analog stick movements, things like that. So I said, why don't I just connect this Xbox controller up with Bluetooth, use the left analog stick for pan and tilt, and the right analog stick for zoom. So I've got that, I'm listening for the events in the browser, I can respond to axis changes, all of that good stuff that I need, right? Next from there, I have an Arduino that connects up to the laptop. I've got a program on that controls a servo that I can drop my webcam on top of, right? So now I have web serial talking to the Arduino. My Xbox controller can listen, I can listen to those events in the browser, do pan, do tilt, and all that fun stuff directly in the browser. You can also use USB, HTML, JavaScript APIs to control the zoom. So that's where I'm going next with it. And finally, just as video cannot be loaded at a video conference. Okay, so there was an embedded demo of the thing working. If you want to see that, come to the AWS booth and I will be glad to show you that. But it's very proof of concept, but it does work. You can actually pan tilt the camera with the Xbox controller. Plan on taking it further. If you want to learn more, come to AWS or follow me on Twitter, Recursive Codes. Thank you.
Hello. I'm Thomas Daede, and I have one of my side projects for you here today. The concept is an open source CRT monitor. So the whole idea here, click, is that we have a tube on the left and is attached not to its original electronics, but to my own electronics. The whole idea here is to basically take the original tube and be able to do a better picture, do more formats than it could originally do higher resolutions, etc. So if we look at this in more detail, what we have is click, is we have a the original tube here. I put in a little acrylic box. There's original electronics in the bottom, but we bypass that, run all the wires out the back, and we run it to my own circuit board, which is here. So this handles the red, green, and blue, the horizontal, vertical deflection, the power supplies, etc. But what is that? Let's take a look at what a CRT needs. Click. We have a control grid. That is basically an element that is, we have a cathode that is heated by the heater. That has a special coating. When it gets hot, all electrons get bouncy and want to fly away. So we help it out with a very high positive voltage. So that flings the electrons, which are negatively charged, toward the front of the screen. They hit a phosphor. That phosphor converts the electron into a photon of light that we can see. We also need to focus it to a point, so there's extra plates with more high voltage on them that focus it down to a narrow point, and then we finally use magnetic deflection to aim at that point around the screen. So basically, when a charged particle is in a magnetic field, it bends. So how do we aim it on the screen? Well, you all know that video basically goes left to right, top to bottom. You store the pixels in a buffer. But before that, when we had analog TV, we scanned it to top in the same order. So the whole idea here is that on like a VGA connector, whatever the red, green, and blue is on there is directly what's sent to the CRT's cathodes. It's displaying the exact color at any moment in time that is presented to it. So instead, all of our geometry controls, all picture controls are mostly done with deflection. So effectively, we have to have our own model of where we are in the raster, and we have to compare it to the video signal coming in, and we move ourselves to match. And the timing here has to be very precise. It's very similar to the clock recovery talks of earlier, but now we have to be accurate down to sub-pixel levels, because if we have any less accuracy, you'll see the picture jitter left or right. So I went ahead and I used modern microcontrollers for this. So I actually have software that talks over serial to the firmware running on this, and it does a software PLL because I have modern microcontrollers that can do hundreds of megahertz or even gigahertz level precise timing. And so I have a software PLL that locks to it, and I can debug, I can control all the software parameters of the horizontal and vertical deflection via software. And I can also do lots of debugging. You can see on this output, I have the input and output timings, how much jitter I have, how many lines, the interlacing, because I support interlacing, unfortunately. So, yeah, that's all I have. There's more videos online at Vimeo if you search for it for open source CRT monitor. And I have a GitHub repository. Thank you.